there, this is a video about atomic size. My name is Dr. Kim. So when we think about atoms and we're comparing their relative size, let's first look at going up and down in the periodic table. So do we think bigger atoms are down here at the bottom or are bigger atoms up here at the top? So this one's kind of obvious. Yeah, bigger atoms are down here at the bottom. So we definitely get larger as we go down a column. So we can say that the trend is to increase as we go down. The size increases as we go down. That's because we're building on a new shell each time we go down in the periodic table. We're going from shell or level 1 out to shell or level 2, out even bigger to shell or level 3, and so forth. So here we're on shell 2. We go down, we're starting shell 3, shell 4, shell 5, shell 6, shell 7. Or level 2, level 3, level 4, level 5, level 6, level 7. So we're getting a bigger radius as we go out each time, each level. What about, however, going across, side to side? Do you think we're bigger over here? Or are we bigger on this side? Well, your gut probably tells you we get bigger as we go across from left to right. After all, the numbers are increasing, 19, 20, 21, all the way to the 30s to 36. So, in fact, that's incorrect. I know, shocking. We're actually getting bigger as we move towards the left. So the trend is to increase as we move to the left. And I know you're thinking I'm wrong at this point, but hang on, I'm going to explain it to you. You have to think about what this number 19, 20, 21, 22 up to 36 represents. What is that number? The atomic number. What does that represent? If you said number of protons, you're correct. That's the number of protons in the nucleus. Does that make the atom get any bigger? No. Okay, now the number of protons equals the number of electrons. But as we go across a row, we're putting electrons in the same level. So that level doesn't get any bigger. Let me show you what I mean. Here we have the nucleus with the protons. Here's level 1. I put an electron there. I put in a second electron. Did that get bigger? No, it didn't get bigger. Here's the second level. Now that got bigger. But that's because I jumped out a level, which is going down in the column. So I put in 1 electron, 2 electrons, 3 electrons. Am I getting bigger? No, I'm not getting any bigger at all. Okay, so at least you're with me now in that we're not getting any bigger. How is it that we're getting smaller? Well, as I add electrons out here, I'm also putting a new proton in the middle. So the number of protons going up. Now remember, electrons are negatively charged. Protons are positively charged. And what do we know about opposites? That's right, they attract. So when I put more protons that are positive here in the middle in the nucleus, and I have more electrons out here, that positive charge is greater. So it's actually going to pull in a little bit. So each time I add a new electron, it's going to pull in a little bit more. And when I add a new electron, it's going to pull in a little bit more. And thus we're actually getting a little bit smaller as we add those electrons on the same level. So if we look at the periodic table, the first hydrogen and helium, of course this is very small, this is even a little bit smaller. Then we jump out a level, so that got bigger. But as we go across, we're getting a little bit smaller each time. And then we jump out when we get to sodium. We jump out to a new level. And we get a little bit smaller as we go across. And then when we get to potassium, we jump way out to the 4th level. And then we get a little bit smaller as we go across. And then we jump way out for rubidium for the 5th level. And then we get just a little bit smaller as we go across. and then we jump way out when we get to cesium, and we get a little bit smaller as we go across. So again, the trend is the size increases down and to the left. Now this is really silly, but if you think of it, it's like a snowman. We get bigger as we go down, and now let's knock the snowman over. Okay, so we knock the snowman over and we get bigger to the left. So we get bigger as we go down and we get bigger to the left. And then here's just a graphic to kind of show you that we are getting bigger as we go down, and we're getting bigger as we move to the left. So that is atomic size, and it's why we get bigger as we go down and to the left. So the why is important. Make sure you understand why. All right, thanks a lot. Good luck.